Your JavaScript code for the EEG _spectrum_16_chan_denoise_music app is comprehensive and seems well structured for processing EEG data and mapping it to musical notes. However, you mentioned a concern about the notes to play always being the same. This might be due to the way the EEG data is being processed and mapped to musical notes. Here's a specific approach to address this. Dynamic mapping in map EEG data to notes. Your map EEG data to notes function should dynamically map EEG data to musical notes. It currently seems to be mapping normalized power values to a range of notes. To make this mapping more sensitive to the changes in EEG data, you might need to adjust how you're normalizing and using these power values. Ensure that the EEG data's variability is being effectively captured and reflected in the normalized values. Review extract EEG data.
I'm just checking the sound still. Just share this quickly just in case someone wants to join in. Get the name without actually that. Can close this because we're actually monitoring from the streaming app as well. It has YouTube APIs, which is great. Just quickly read this again.
Your JavaScript code for the EEG _spectrum_16_chan_denoise_music app is comprehensive and seems well structured for processing EEG data and mapping it to musical notes. However, you mentioned a concern about the notes to play always being the same. This might be due to the way the EEG data is being processed and mapped to musical notes. Here's a specific approach to address this. Dynamic mapping in map EEG data to notes. Your map EEG data to notes function should dynamically map EEG data to musical notes. It currently seems to be mapping normalized power values to a range of notes. To make this mapping more sensitive to the changes in EEG data, you might need to adjust how you're normalizing and using these power values. Ensure that the EEG data's variability is being effectively captured and reflected in the normalized values. Review extract EEG data for music. Ensure that extract EEG data for music function is extracting a diverse range of data from different spectrums. If the extracted data lacks variability, this could lead to the same notes being generated. You might need to tweak the logic here to capture more nuanced aspects of the EEG data that can translate into different musical notes. Verify EEG data variability. Check if the incoming EEG data itself is varied. If the data lacks variability, the output notes will likely be similar. Adjust normalization ranges. In normalized power, ensure that the min and max power ranges are set appropriately for your EEG data. Inappropriate ranges can lead to loss of variability after normalization. Testing with different data. Test the application with different EEG data samples to see if the output varies accordingly. This can help you determine.
So this is actually the first time for me that GitHub Copilot gave a better response than GPT-4. So over here, we try to normalize the power with each frequency band, because this display can see this number showing absolute values. We want them all to be, say, between 0 and 1. By the way, this is the only case we actually get a different note. Before I like was getting C3, F3, B3, E4. And for this, what is it, 5 seconds of EEG, I get the C sharp instead of C. But that's not good enough. We want way more variability in the notes. So that's what we will be addressing today. And GPT-4 was suggesting doing it manually instead of using math min max functions. Only when prompted to use math min max, it's producing the same response as the GitHub Copilot. Just check if GitHub Copilot made any other changes. So we have this normalized power. So yes, it's making other changes as well. That's just the structure of it, is it? And we can insert it into the code. Yeah, so we calculating min max is straight from the array. And let's comment this out quickly. And let's try it out. Yeah, let's make having the same notes plate. Let's check if that code is actually working. And let's console log it. Don't need this comment. Console log and max power. Was it 60? Yeah, it's doing it for each band. Just clear. Okay, some errors as well. That doesn't look right. So doing it for the whole spectrum. So we need to turn this off. Right, this is better. So we'll have a 1296, and then the next power, yeah, will be just under 12. Yeah, the whole spectrum turned off by default. But we can do it in HTML. To do this with GitHub Copilot. Yeah, this switch, can I explain this for us quickly? I assume that's the default value. How to change default? Just remove the checked attribute. Let's try this. Yeah, Control 5. Gonna check the values. Yeah, min power is around 0. Max power 396. That makes sense. And then we have 196. Yep, that makes sense. Get some errors as well. Frequency undefined in JavaScript, line 86. All right, so this duration is 1. By default, I think we're setting it at 2.5. Volume should be fine. We're getting an invalid frequency. That's interesting. What is the frequency? It's just missing. noise powers, map noise. We get the nodes, so the nodes to frequency conversion. Potentially doesn't work. Yeah, this node to frequency conversion might be producing something funny. And let's call this fric. And then return fric. That's right. We want to monitor fric log. A console. So it can generate will return node and the frequency component. Let's do that, see where the error is coming from. Node C3. Oh, that's a different error. Frequency B3 frequency, 4 frequency. Okay. Okay, the nodes and frequency conversion seem to work fine. But then I'm getting something undefined. It's a bit odd. Sort of technical issue. I can hear the notes being played. So what that error is coming from. Well, I know where it's coming from. I don't know why I'm getting it.
The issue you're encountering is that the map EEG data to nodes function is generating an array of node names, like C3, F3, B3, E4. But when you try to play these notes using the play frequency function, it's expecting frequency values, not node names. As a result, undefined is passed as the frequency, leading to the error. To fix this, you need to convert the node names to frequency values before attempting to play them. This can be done using the node to frequency function you've implemented. Here's how you can adjust your code. Modify the part where you play the notes. Use node to frequency to convert each node name to its corresponding frequency. Pass this frequency to play frequency. Ensure node to frequency is correctly implemented. Double check that your node to frequency.
It currently converts the names to frequencies, so that's happening. I thought I'm already doing this.
In this adjusted code, the for each loop iterates over nodes to play, which contains node names. Each node name is converted to a frequency using node to frequency. The frequency is then used to play the sound. Ensure that your node to frequency function covers all the node names that your application might generate. This change should resolve the issue of undefined frequencies and allow your application to correctly play the map notes.
Yeah, that error went away. Yeah, I was getting the same notes. Show for channel 4. It's not working anymore. Let's just double check. Delta should be in 155 or something. Power. Yeah, it's this one here, 163. 163, and the second one is 31. It's that one there. So that's legit.